Hey everyone, it's Chad here. Today we're tackling the LeetCode problem, merge intervals. I'll walk you through how I'd solve this in a coding interview, from understanding the problem and devising a plan, to coding, then testing for errors, and evaluating time and space complexity. I'll be solving this problem in Python and I'll think out loud and ask clarifying questions just like in a real interview scenario. Let's get started. First of all, let's try to understand the problem statement. So I'm given an array of intervals where intervals I is start I, end I, and we want to merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. So if I reformulate the statement here, so we're given as input intervals. There's a list of lists, and the first list gives different start I, end I's that each, where each of them represent an interval. And when we say intervals overlap, it just means that we have, let's say, 1, 3, and 2, 3, for example. And we can see here that 2, 3 is already included in here, so we can actually remove this. So this is what overlapping means. And we want to return an array of the non-overlapping intervals that cover all the intervals in the input. So we want to return only, so an interval that actually includes all the intervals that were initially present, but without being, being overlapping. So let's actually go with this first example actually to dive deeper into this problem. So if we take this one, first of all, we can note one thing, that is start I for each of these intervals, these intervals are sorted according to start. So 1, 3 is actually one interval. And let me take this one. Then when I consider 2, 6, what I see here is that 2 is between 1 and 3 because we have 1, 2, 3, right? So I can actually merge this one with 2, 6. So I can say the new interval I do have is 1, 6. Then when I have 8, 10, what happens here is that 8 is over 6, which means that there's no overlapping between this interval and this interval. So I can leave it that way. And when I consider 15, 18, 15 is over 10. And it is over. So I have to, so I know that the last interval that I introduced in there has the highest endpoint, right? Because if this one had an end that was over this one, well, this would have been merged, right? So I just have to confirm that 15 is over 10. If that's the case, then can put this way, and this is the final result that I would give. Let me confirm that this is exactly what we have as a result here: 1, 6, 8, 10, and 15, 18. So now that I've went through this example, let me first of all ask a few questions. So what are the type of start and end that we could have? Can the start and end be negative? For that, we have the answer here that is given. Start and end are between 0 and 10 to the power of 4, which means that it's never negative. Second thing is, can the intervals be empty? If intervals is empty, then, there's no merging needed. If there are at least one interval, then we can just return the one interval. And I just want to confirm also that for each of these intervals, we do not have any errors. So my question was, can we have any interval that is not well represented? That's not the case, because we know that intervals I length is always 2. And then I want to ask the question, can the numbers be inverted? Like, can we have start after end? So is it possible to have start higher than end? So we do not have any oh no, yeah, we do have start I is inferior or equal to end I, so we have the answer to this question too. So yeah, that's all. Now let me try to devise a plan for this problem. So for the intervals, I can see the result as being as a stack, right? And this is the result, and this is kind of a stack, because when I'm introducing a new interval, I'm considering a given interval. So first of all, my first idea is to sort according to start. Once that's done, I want to take this interval and compare start of the start with, if start is strictly superior to result -1, and so that is 1. If this is strictly inferior to start, then it's pretty simple. We know that this interval is not we will not have any conflict with this one, any previous intervals and this one. No overlapping. But if that result is not strictly inferior, is strictly superior to, if start is not strictly superior to this one, so we want to find all the intervals that we want to find the ones that get overlapped with this one. So for example, let's say this is not 8, but this is not 8, but let's say this is 1. Then what happens? Well, we see this one before inserting, we look into this and we're like, okay, this one is lower than this one. So this interval and this intervals are overlapping. Then we consider this interval and this interval if this one is overlapping with this one. So while result minus 1, 1 strictly is superior or equal to start, what do? Well, we pop it. We pop from the stack. There we go. We pop this one. And we see that this one is even lower than this one. This should not arrive here. Let's say this is not the one that I change. Let me leave it to 8. Let me put this one to 1 so that I can show my case here. So let's remove this one. I have 1. So this one is higher or equal to 1. So I pop it out. And this one is higher or equal to 1. So I pop it out. And this one is higher or lower to 1. Pop it out. While result is not empty and I have this, I can pop the interval from the stack, and what I do by the end is, and I would choose the minimum between and push the interval with the minimum start between start and the one that got popped. Popped interval start. So what happens here, for example, is that we end up with 1/6 and 1/18. The thing is, this should not happen, right? Did I really have to actually sort the intervals according to start? Because if I do sort it, I will not have this error, right? I can actually remove this and say, yeah, we do not need this. I don't need, because this is n log n, right? I don't need to sort this out. I can just leave it this way so that, and when I pop it, every single time I pop this one out, does this make sense? No, I need to sort it out, because if I do not sort it out. Let me sort it out. And so this will not happen because we know that this one will only have. So let me remove this. Yeah. So 1, 3, 2, 6, 8, 10. And this should be over. I think it was 15. So the only way these intervals can actually get merged is, okay, this is not happening. So when I have one interval, I just have to compare this one with the previous one, and the previous one, if it does have a maximum value that is higher or equal to, so I just have to look into the previous one. If that one has its end is superior or equal to this one, then merge them. And how do we merge them? We take the minimum for start and max for end. There we go. 8 and 10. Let's say I have 9 here. So this one should get merged with this one. 9, 18. So this one should get merged. I get 8, 9, so it's 8, 10, 18, it is 18, and there we go. There we go. That's it. And when we have went through all the intervals, we have the result and we can return it. Now I do have this, and the time complexity for this one would be O n log n, where n is the length of intervals. And my question now is, do we have to sort the intervals? Can I solve the problem without sorting them? Let me take the first example from here and change it. I'm curious about this. Well, I have this interval, and if I do have this, then when I look into this one, I might have to see if this one is overlapping with any of the intervals before. And in the worst case scenario, what can happen is I would go back and forth with all the intervals to actually merge them. So if I have this one and I have another interval that should get merged, well, I would merge them and put them there. Then I would check, okay, this one should it get merged with all the intervals before that? Okay, I have to check if this one get merged. Yeah. Yeah, I think we can go with on log the n, log n. Yeah, I can. So let's move on to carrying out my plan. So first of all, if let me create result that will store the results and go through for start and end. For intervals, start end is gonna be interval 0, interval 1, and let me sort this one. Intervals is sorted. I would ask the questions is, can I sort the given intervals? And if there's no issue, I would just sort key lambda. So it's an interval 0. There we go. So what I'm doing here is I'm sorting the intervals according to this lambda function that takes one parameter that is an interval in there and is using its start to actually sort it out. And then for interval in intervals, start is the first value and end is the second value. And what do? I have to decide if I need to merge this interval with the one already in. If result, what I mean by this is if result is not empty and result -1, so we are looking into the end of that one is inferior or equal to, is it superior or equal to start, then we should merge both of these intervals, right? Exactly. So which means that I can say so we would append minimum between start and result. Let me previous interval should be start previous end is gonna be result pop Okay, let's call this previous simply pop, and this one would be previous 0 and maximum between end and previous 1. And there we go. So this is what we would be appending to result. Else, there is no overlapping between the previous interval and this interval. And there's one problem with this one, right? Let me think about this one. So let's say, is it possible actually to have one previous interval in conflicting with this one? Let's say I have one interval that is this way, okay? Tac, tac. And one other interval that has an, so we know that start is being it's sorted by start. So we might have these two intervals in the stack, right? And now I'm introducing this new interval. So is it possible for this interval, so we know that this interval and this interval does not have any overlapping because it got introduced in there in our result. And now what I'm doing is I'm putting this here. Is it possible for this interval to have an overlapping part with the previous interval? Because we know that this interval is not overlapping with this one, and that this new interval has a start that is higher or equal to this one. So it just means that this interval cannot have any overlapping between any of the previous intervals. So yeah, this makes sense. So we can simply, so if result and result minus 1 is, then we can have result append this new interval. That is start and end. And that's it. We can return result. And now let me check this algorithm here with the second example that is given here. So we are considering first result is empty. So as the interval is empty, we are iterating over intervals. So it gets sorted first. So 1, 4, 4, 5. 4 is bigger than 1, so intervals is sorted this way. There's no problem with that. With result being this one. And then we are going into the loop and start and end is 1 and 4. And if res is empty, so we go here and we are appending 1, 4. Now that we do have this, we move on and 4, 5. And because 4, 5, res is not empty and res minus 1, one is superior or equal to start. So this one is superior or equal to start, which is the case. There's overlapping. And when there is overlapping, we pop it. And then we choose 1, because that's the minimum between 1 and 4. And 5, because that's the maximum between end and previous one. And the result is being then appended 1, 5, with this as the result. Yes. Now let's run the code. We do have the answer that works, and let's submit the solution here. Yes. And now that we do have this, let me give the time complexity that is because we are sorting the intervals first here, it's n log n, as I said earlier, and here it's O of n, so it's n log n, where n is length of intervals, number of intervals, and space complexity is O of 1, because the result array and the input array are not counted in this. That's it.